this video, we are going to cover the MATLAB approach. And the MATLAB approach using the lagged variable will be the 17th video here. I already have a MATLAB approach here using MATLAB Regression Learner, also artificial neural network. So those are already here, but those are not using the lagged approach. So now we are going to continue with the data set we prepared in the lagged approach. So here, this is the data set we prepared for lagging of 12 months. I have to prepare it a little bit more in a different way when I'm going to use it in MATLAB. So one of the first things I'm going to do is I'm going to create a new MATLAB file. So I call it MATLAB. Here, in generally, it's best to not have like variable names like these with gaps, with different types of symbols and so on. So it's best to not have like that. So we are going to do some cleaning and things like that. Okay, but I'm also going to remove all my all these other files from this template, because in MATLAB, when we upload the Excel file, if we have too many files here, it will be confused. It might be tricky for the software. So I'm going to remove all these templates from here. Here we did the forecasting here. I'm going to remove this accuracy metrics and things like that. We keep the lag. That's okay. So if you do not know how we did the lagging, you have to watch the video number forecasting 16, where we did the lagging of the lagging of the time series data. Okay. Yeah, I'm also going to remove the figure. Also all these ones I'm going to remove from here. Oops, no, I didn't select them properly, so I'm going to remove them from here. So this is our main data structure after doing the lag. Yeah, that's it. So actually here I'm just going to call it BCI C3. Maybe if I call it like this. Yeah, we introduced 12 black. So all the variables are with 12 black. So IP China, IP Brazil, cape size, let's see, scrap, quarry, spot, thermal, coal. We can just call it coal price. Port congestion, speed, order book. So we simplify our data and variable names. Okay, so this is something. It's good to normally do this. We are going to use the Regression Learner app in MATLAB. So if you use the Regression Learner app, you have to prepare the data set in a certain way. If you use the neural network app, you have to prepare the data set in a little bit differently. Okay, so we are going to do the Regression Learner app, and here we can have our input and output variables in the same file. We just have to take out our outsample data. Okay, so here this could be our main file, main data with all the variable. Okay, now we are going to create one. We call it input. My data name is becoming very big, but it's okay for now. If we can keep track of it, it's okay. Yeah. So I'm going to call it input, and here I'm going to create another one. Save as. Going to call it outsample. Okay, so in the outsample, we cannot have anything except for only our outsample variables. Okay, so that's it. I'm going to remove all of it. We can now also remove this column from the outsample. So outsample data set would look like this. Only the data of my only the data of my variables, input variables. That's it. Okay. So I just keep it like this. I will go back to my input one. Okay, I go back to my input that I created. Here I do have also the main forecast variable, like target variable and also the input variable. I'm just going to remove the outsample data from here. So here I will have my main variable and these are my input variables, right? So those are okay. Those are okay. Yeah. These are the data that I'm using as my input. I'll just put a shade here so that it's easy for me to see. And this is my main dependent variable, and these are the values I'm going to delete. Okay. So that's my data preparation for MATLAB input data file. This is the variable we are going to predict using these variables. Okay. Normally, because we are following a lagging structure, we should have a large sample size. Like here, I have like 3 years, right? Yeah, 4 years. I have 4 years here. It's good to have like as large as possible. Okay, 10, 20 years, something like that. So then we can actually lag more, forecast more periods, and so on. But anyway, so I'm just proceeding with this approach. It's easy to visualize here or like demonstrate with the smaller data set. I have my MATLAB open here. So you have to make sure that you have MATLAB from your institution. It's a subscription-based software, so you have to have access from your institution. And while installing the app, we have to, this regression learner app that comes under the statistical and machine learning package. So make sure to have it. If you don't have it, you can just go install, and here you can search with the statistical package and machine learning package. You install that, machine learning and deep learning package, you will have it. So now we go to regression learner. It will open up a new window. It takes like few seconds or something like that. Okay, so here is our regression learner app. It's empty. It looks like this. So here we can now load our data that we have prepared, and then we can train a model and see how it looks like. So here we can start a new session from our workspace, or we can load a new file from our computer. So in my case, my workspace is set to the folder where I have all the data. So actually I can take it from there, or I can also take it from my file. So let's say I take it from my file for now. Here it is. I have created so many files. I have to pick the right one. So this is the MATLAB input. That's the file that I'm working with. Yeah. So this is how it, when you load it, it comes up with a window that will normally tell us, some information about the variable and so on. Yes, our data is loaded now, and it looks all right. We have the variable names here, so it's okay. If we didn't have any variable names, you would take no variable names, but everything looks actually okay to me. So I will just go and select import selection. And now importing the selection. As soon as we import, it runs it starts to draft a very simple model called trees. Yeah, it's coming up. And here we have to say, okay, this is our table, which is our dependent variable. So what is it that we are trying to forecast? So this is one we are trying to forecast, BCIC3. So we have to say that BCIC3 is what we are trying to forecast using all other variables. So here we call them predictors. This independent and dependent variable in a statistical term, then in machine learning term, we call the dependent variable target and all the other variables input. In MATLAB here, we are calling the dependent variable response and all the other variables predictors. So you can say them in very different ways. Here, we can use cross-validation, we can use holdout validation. So there are different validation approaches, but for now, let's say we pick cross-validation. Our sample size is very small, so I will pick only 2 cross-validation folds. We are going to have some training data. So normally it's a very standard practice to set aside some test data, but here we have already separated some test data, right? So in this case, I can avoid it, right? If I had a larger test data, I would maybe select this. My sample size was big here. I'm dealing with only like, uh, only like 4 years of data. So, but if I had a larger sample, like 500, 1000 observations, it would be nice to keep actually 10, 15% of the data for test. But now I can still keep it, or I can just not keep it and just train the model. So I will, for now, I will not keep it. So you guys play with it, see how it looks like. You will see how the results come up. So I'm going to start session. So here it's, yeah, as I said, it's when we load the data, it creates this draft simple tree model structure. So here it's not trained at all. So, but I can now, since it is there, I can actually select it and train it. So I say train selected. Now we can quickly see how the results look like. So the model is not yet trained. It's still in the draft. Yeah, it's queued for training. The MATLAB software is not like very fast, it takes like it also comes with lag. So we click and it takes like few seconds, sometimes a minute or two to get some things run. Okay. Yeah. So now here we see our validation RMSE average is 5.57. If we compare this with the lagged variation, with the lagged approach that we did, we can actually see if it's higher or lower. So let's have a quick look. If I remember correctly, I think it was lower than this value. So here we have in MATLAB 5.57 and our MSE was 31, right? So in our lagged regression approach, it was here. We had, yeah, RMSE of 2.9, so it was much lower. MATLAB, it does not really give the MAP by default, but we can do the coding of it, but I'm not going there. You can try to find it. You can Google about it and try to find it. And here we have the response function. So here it shows like the predicted values. So the real values for the data periods, here on the horizontal axis, we have the data periods, and here we have the freight rates, okay? And the yellow ones are the predicted and the blue ones are the real data. So we can see the gap. If you click here on the errors, you can actually see the difference in different cases. Okay. But anyway, so now this was the base model that it shows by default. But here, this step, I can actually go and train all the models. Okay, all the models they have in the library. So we can actually do. So they have linear regression models, regression trees, support vector machine, uh, some Gaussian process models, kernel models, ensemble trees, neural network trees. So they have a lot of models. So what we are going to do, we are going to use the linear model. We are also going to use, let's say, we can add the linear SVM. We can also go, let's say, and use you can play with all of them, but let's say I select one of the ensemble trees. So I select, let's say, booster trees. So these are the three models I choose, and I'm now going to train all the models, all these three models in my draft. Okay, with the default setup. You can also play with this, setups, change them and see how it looks like. So I think it will take 2-3 minutes. So I will pause the video here and I will come back when the training is done. Okay, so we have now the results. It actually took less than 1 minute. And here we can see the RMSE validation and SVM validation and ensemble validation. So we see the RMSE values. The RMSE values here, they are higher than the value we have here, right? One of the reasons could be that here we had twofold cross-validation in MATLAB. So when you do cross-validation, often your accuracy decreases a little bit, But even though your cross-validation accuracy decreases, often when we train models with cross-validation, it gives higher accuracy when you are predicting outsample. Okay, with new data and so on, it increases the generalizability of the models when you are actually predicting outsample. We actually very recently published a paper about it. If I quickly go to my Scholar, so it came out actually just like I think today, yeah, 2 days ago. So this one here actually in this paper we actually show the effect of cross-validation samples, cross-validation on the accuracy of forecast models. But anyway, uh, now we have the results, right? Here we did not select any test sample when we are setting up the model. So here actually in the test, we cannot really see by default, but we can load some test data and see the results. But for the test data to see, the accuracy and so on, we also need the the real data of that period and the test data. But in our case, the outsample period we have January 2024 to December 2024. For that, we do not have the real data of the target variable, the real freight rate. I mean, now we have it, but now we can get it from Clarkson, but theoretically we don't have it in this modeling approach. So basically, we cannot test for that, but we can use for prediction. Okay. So, and then we also have these different things to see, how different variables are having an effect. Um, the Shapley and Lime, these are two most used approaches to see which variables has the highest effect. So let's see if Shapley works. Here I have selected the regression model. So here, whatever model you select and then you click on something, it will give you the outcome for that particular model. Okay, so it's taking a little bit of time. So we have the Shapley values here. Here, this is our response, the predicted values and the real values for this linear regression model. So from Shapley, what we see is order book has the highest effect and it has the negative effect. So the more order comes up, the freight rate goes down. ORE spot rate also has a negative effect. The more ORE spot rate goes up, the freight rate goes down. Then these variables has a positive effect. So the more put congestion, the more freight rate going up. The more capesize scrapping, the more freight rate going up. The lags, the higher the lag, 12 months lagged freight rates, the future freight rates are also going to be higher, and so on. So this is actually very in line with the theory we know. We know the more supply we will have in order book, the freight rates will go down. ORE spot, we know the higher the price of some commodities, the 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 lower is going to be the freight rate. So we know that this association. And then for congestion, we know congestion reduces supply. So the more congestion we have, the more will be freight rate. For scrap also, the more scrap we do, the more will be the freight rate because it reduces supply from the market and so on, right? So now let's have a quick look into how we can actually implement prediction of it, which is a tricky part, okay? So here you can actually use any model for prediction that you want. Let's say I pick this one SVM because this has the lowest RMSE. So let's say I pick this one, I select this one. And when we select the model, so for prediction, we have to actually follow a couple of steps. So the first thing we have to do is we have to export the model, okay? So we have to export the model, and after exporting, we have to run these two lines of code, okay? So first, let me export it. So I export the model, and here we can give a name to the model. So let's say here I call it SVM model. The simpler we can make it, the better, okay? So normally I wanted to avoid any caps and so on, but let's say we call it like this, SVM model, okay? Yeah, that's okay. Now it's exported. We can go now to the main MATLAB window. So far we were on the Regression Learner app. Now we came to the main MATLAB window, and here we can see our model exported. Now I'm actually going to copy these two lines, and here I'm going to replace it with the name of the model that I have given. So now I called it SVM model, so I replace it here. And these two lines I'm going to copy. Here also the file name of the output sample. Okay, so I have to change that too. So I'm going to copy this. Oops. I copy this, I put this here. Here my file name has to match exactly with the file name I have prepared here for my output sample, which is here. This one. It has to match exactly with that. It has to match exactly with this. We were trying this in the class last time, and we were also getting this invalid text character. So basically this means that this symbol does not work. So we have to update the symbol to this, and you know that the symbol works when the color changes to this. Okay, so we do it like this. Now our T is loaded. So T is basically the outsample data file, and then we are just going to copy this, which is the function for prediction. So we just put it, and now we get the forecast of the future. Okay, so that's it. Now we can actually just copy this number of forecast. We put it in Excel file. So basically, if I go to my lagged regression approach, so this is basically these values of the forecast. You know, these are basically the forecast from MATLAB. Okay, so these are basically the MATLAB forecast. And now we can actually see if the forecast values differ from our multiple linear regression in Excel, or how actually they are in our how they are from our MATLAB model that we did in MATLAB model that we did in MATLAB SVM. Okay, let's see if I can actually add them here in this figure. Select data. Oops, stop. I just want to add one additional. Add a series name, series values. All these are 0, but here we have the data. Okay, then okay. Yes, then we see the MATLAB forecast series here, this part, right? So this is how we can actually visualize the forecast and get the predictions from MATLAB. So I hope you find it useful. Similarly, you can actually do any regression model using the regression learner tool. So play with it, try with other models, try with also the different neural network models, try with different configuration of the neural network models. Okay, cheers. Good luck. Bye-bye.